Good morning, Bhanu.
Good morning, Tim.
Thanks for joining. How are you doing today?
Doing good. How are you?
I'm doing all right. Thank you. Thank you. Got my coffee. Got my 7-year-old to Montessori for online class. I'm good.
Nice. Yeah, lazy Friday.
That's right. Hey, you know when you were very nice the other day when you understood because you had flooring going on in your house. My flooring guys finished all in one day. It was Tuesday morning when they started and they were done on Tuesday evening. So I don't have any loud noises or anything to mess up today.
Same here. We were wondering to do it in 2 days, but like literally they started at like 9 and finished at 6 non-stop. I was
Nice.
surprised.
Nice.
Yeah.
So I should be sharing a slide that just says we will start at 9 a.m. Eastern.
Got it.
Hey, Prashant, how are we doing?
Hi, hey Tim, can you see me okay and hear me okay?
Yes.
Okay. So, all right, I had to switch the account because the forwarding does not work with Teams Live account. So the original invite I had to open up and use that account. That's why it took me like a couple of minutes to join.
Okay.
So how's everyone doing today?
Doing good.
Not bad. Not bad. How are you doing?
Doing good. So Tim, regarding the intro, in the upload section, I just add a couple of slides for with him. So how shall we address that?
I already did this. I already have a.
Okay.
I mean, I have a with them slide. Can you see this?
So I can see, okay, I can see the YouTube channel, that slide is there, okay. And then.
Hold on 1 second. This is weird. We will start at blah, blah, blah. That didn't show.
Yeah, this should be fine. All right. So you good talking about with them or shall I do that?
No, you can talk about it.
Okay. All right, then I will have some notes ready. Okay.
This green flashy stuff on the side of the left panel. I don't know if you can see it, but I can see it. It's like it's flashing green. I just don't want the audience. I want the audience to be able to see.
No, okay. So I joined as an attendee, and all we see is your slide deck. That's it.
Okay, good.
Just want to make sure, you know, we're good on that front. So now we see, and by the way, Teams Live event is like there is a delay for 2 minutes or like less than 2 minutes. So what we see in this meeting is little like there is a lag. So now I see like you going through the deck and other stuff.
And then we'll monitor for questions and all that stuff.
Right. Yes. And just a heads up, I will be on baby duty, so my son will be with me. He's quiet. So after this, like once this is launched, I will be going to the living room. But I should be okay in terms of you know, monitoring the sessions and you know.
No worries at all.
Yeah, this is kind of interesting. Nobody thought like, okay, we'll be having this kind of situation, right? Who knew, like 10 months before?
No.
So normally this used to be an in-person, is it?
Yes.
Oh yeah. We would do these in Reston, and they've done them in Philadelphia and Boston, Atlanta, San Francisco. I think they tried to do one in Seattle.
So the big difference between in-person and the virtual is in-person, you need to do a lot of prep work in the beginning. However, during the conference day, once, you know, everything is set, you know, the keynote started, then you can kind of take it easy. But in virtual conferences, no, like you need to have one dedicated person for each track or maybe two person, and then it's more work during the day than as compared to before the conference.
Yeah. Like I'm tired as heck after the virtual stuff. This is our third virtual conference.
I see.
We did one at the 1st of July, one at the end of July. Hey, Adam.
Hey, everyone. How's it going?
I'm doing all right. Are you and Bhanu going to speak during the first keynote part, and then Adam, just you for the general session, or how's that go? I forgot what the division of labor is, because I didn't want to introduce you incorrectly.
Mine is the first, and after that it's Adam.
Okay.
Yeah. So Tim, do you want me to be available after my session is done, or like I can be there only as optional after my session is done?
You can be optional. You can go. You can do whatever you need to do. Yeah, we don't. I just block the time off for people to know that it's coming. That the set, that you were set to speak. But when you're done, you're done. You're good. Thank you for asking.
Okay.
And then Tim, just to confirm, when we get to the point where like my session's over, the transition back, I'll probably say something like, hope you enjoy the rest of the Azure and Data and AI Fest tracks and sessions, and have a good rest of the day. I'm gonna transition it back over to Tim.
Yeah, and we'll throw this back up on each of the 3 tracks.
Okay, perfect. I just wanted to nail that down. So okay, cool. Sweet. Still waking up a little bit here, but should be ready to go in about an hour.
All righty. Well, we'll start at it's 9 a.m. on my laptop and 9 a.m. on my phone. We will start in a minute because there is a delay. So
okay.
Okay, we will start at 9 a.m. But we'll do 9:01. I'm waiting for my little clock here to switch over to 9:01.
Right before you do that, is there going to be like live Q&A, or because of the delay, just keep going forward?
Right, because of the Teams live, they only have the text-based Q&A. So I'll just queue up the questions at the end and throw them at you.
Okay, cool. I'll try to leave a little bit of time for that. But
yeah, because the questions come 20 seconds or 30 seconds after you've already made a certain point.
Got it. Okay.
Oh.
And Bhanu and Adam, are you fine with posting your LinkedIn account details in case attendees have any follow-up questions?
Yeah, I'm fine.
Okay. All right.
All righty, we'll get started. So on behalf of Prashant Boyer and myself, I'm Tim McAlilly. Welcome to the November 2020 Global Azure Data and AI Fest. This will be our 3rd one. We did a full 7-track, 8 tracks event at the first part of July 2020. And then we didn't think we had enough torture in our lives, so we did an AI and ML Fest on July 31st. So we still haven't had enough torture. So we're going to do this conference today, and it's more of a mini conference. We have Bhanu Prakash. He's a principal program manager from Microsoft to talk about Azure Databricks. And then we've got Adam Wasserman to talk about Azure Databricks for like a technical session. And then we'll break into our tracks. We'll break into a data platform track, an AI ML track, and a data and analytics track. 1 second. So I want to pass it over to my partner here, Prashant, but Prashant also knows a little bit about Witham.
All right, thank you, Tim. Welcome everyone. Witham is the official sponsor for this global Azure Data and AI Fest, a November edition. And we at Witham, we provide a variety of services like audit, tax, and advisory. And I work in their advisory division, where we have a multitude of services like digital solutions, data and AI and analytics, cybersecurity, SOC audits, We have done a lot of projects in the Microsoft ecosystem. We are Microsoft partner from last 17 years, and we have 2 Microsoft MVPs on the staff, and we are actively hiring. So if you or anyone in your network is looking for a change, do not hesitate to reach out to me. With that, I would like to pass it on the control to Tim.
All right. Well, thank you very much. And again, thanks to Witham. So listen, we've got the crowd is slowly trickling in. We've got about over 25 attendees right now, but we've got over 500 RSVPs. That's really strong. So thanks in advance for attending, and make sure we thank our speakers and proctors and staff. As you're moving throughout, we have our event schedule here at aka.ms November 2020 Global Azure Data and AI Fest. After the event is over, you can download speaker slides at aka.ms downloads-fall 2020 data fest. We have a YouTube channel that hosts basically all of our recorded content. So aka.ms Azure Cloud Events, and there'll be a channel called November 2020 Global Azure Data and AI Fest or something, and there'll be 14 new sessions. Oops, sorry. You can also follow us at meetup.com NovaSQL or meetup.com Artificial Intelligence and Machine Learning. There's also a global Artificial Intelligence and Machine Learning, and you can check out those meetups to find out information about our next Azure Data Fest or Data and AI Fest. We'll have one on February 5th, one on April 2nd, and one on June 4th. We'll probably make those mini 2 or 3 tracks as well, because they're just a little bit easier to manage. So go out to the meetup sites and check things out. So with that, I'm going to hand it off to Bhanu Prakash, and Bhanu's a principal program manager with Microsoft, and he's here to talk about Azure Data. I say Azure Data Fest, Azure Databricks. So Bhanu, I'll pass it off to you.
Awesome. Thank you, Tim. Let me go ahead and share my deck. Let me know if you can see it, and then I can get started.
Yep.
All right. So good morning, everyone. My name is Bhanu, and I'm a program manager in the Azure Databricks team. And today I'm going to talk about modern data engineering with Azure Databricks. First of all, thank you for everyone to coming on this Friday morning to hear about the different data services on Azure and how it helps to harness and democratize the data that you have in your organizations. So let's go ahead and kick this off. So as you know, like data is the catalyst for innovation across literally every industry worldwide. Like the amount of data that is being collected and made accessible to you is growing dramatically. Whether you talk about construction, customer experience, commerce, retail, restaurant, theaters, airlines, any industry, the rate at which the data is growing is astronomical. So if you look at some of the data points from the IDC white paper, basically there are 3 things that are shaping the future innovation. The first, if we talk about the data growth, it's expected to grow to almost 175 zettabyte by 2025. And then almost 80% of the organizations are investing in AI related technologies, which is expected to grow up to like 300% through 2023, which is like a major trend. Tim, like as I'm going, if for some reason there is network issue, feel free to let me know, because I may not know. So just
Sure.
relying on the, yeah. The other data point from the Gartner prediction is that by 2030, the global business value derived from advanced analytics and AI will be $15 trillion. But what are the barriers to realizing that business value? Like there are good data points and predictions being made, but there are certain barriers today that prohibits businesses from realizing those values. And so if you look at some of the common challenges that are slowing deriving value of analytics, big data, and ML projects, fall into three big buckets. So the first one is around complexity of solutions. With so many options in the marketplace, your workplace, your talent developing across different technologies out there, you end up with so many technologies that it becomes complex at the end to build an end-to-end solution. And second is around the siloed data teams, like different teams, different data teams across your organizations. They inhibit the development of unified data pipelines. And lastly, with these complexities, many companies find it hard to scale their workloads efficiently. There are scaling and performance constraints that represent cost and implementation barrier for data engineering teams. So if you look at in terms of the organizations dealing with these problems, less than half are satisfied with the ease of their analytics software, and only 21% are actually satisfied with their access to semi-structured and unstructured data, which is where the data growth is. And then only 28% are satisfied with their ability to scale to unexpected requirements. So on one hand, while we see there is a value, on the other hand, we see there are some challenges. And so handling those challenges requires a modern data engineering strategy. And this is where I am here to talk about how Azure Databricks solves and helps you define a modern data engineering strategy. So Azure Databricks is a jointly developed data and AI service from Microsoft and Databricks to help with data engineering, data science, analytics, and machine learning. It enables the data science, data engineering, and business analyst teams to collaborate more quickly, more easily, and in a nice to use manner. So if we look at at a high level what Azure Databricks is, the focus is on enabling your data teams to be productive and help them harness all your data. You don't want them to spend a lot of time defining, creating, and going through all the challenges we talked about. It allows them to build an open data lake with Delta once and then leverage it for all your use cases multiple times. And it integrates securely with your existing Azure ecosystem. So when you put this all together, what this comes down is, if we go from the bottom to the top, let's summarize what Azure Databricks is. In the previous slide, like I mentioned, Azure Databricks is a managed service on Azure, and everything that I just spoke, you can have deployed in your Azure environment with just a couple of clicks. And it takes literally a couple of clicks to spin up your Azure Databricks workspace. So on the bottom, we have the data lake. You leave it as is. And then you create a Delta Lake on top of your existing data lake. It's just a storage format. And with that, what it allows is it gives you consistency, reliability, and performance to your existing data lake. Now, once you have your Delta Lake, what we have is Delta Engine, which brings high performance to all your data workloads. And the final layer is focused on providing purpose-built user interface for your analytics data teams, machine learning, ad hoc BI, and so on. So from a data science team's perspective, what we offer is a collaborative workspace that's fully integrated with ML flow. So think about data science workspace as a portal that your users go into, from configuring clusters to having it run with ML runtime or regular Databricks runtime, to a managed ML flow registry and tracking service, to notebook, or connecting with your ID of your choice, is all available within Databricks with just a single click. Okay. So let's talk into, in a nutshell, what this comprises of. So I talked about the personas. So in terms of personas, it's the data engineer, data scientist, and business analyst. So Azure Databricks provides a unified collaboration and a simple and collaborative environment that enables your entire team to interact with data simultaneously. It's a scalable, reliable service that is already processing like millions of server hours running per day and processing exabytes of data every month across like 30 Azure regions. You can create clusters like within seconds to minutes, and that can dynamically auto scale. Like you don't have to worry about whether you start with 2 node or 4 node, like you just give a number and then it can auto scale based on your load. And we have made advancements to the Databricks runtime to make it almost up to 10x faster than open source Apache Spark. It has enterprise-based security with encryption, fine-grained access control. It's high trust certified, built on foundation of HIPAA, SOC 2, and so on. And with these industry standard certifications, Azure Databricks is used for data and in AI across a variety of industry use cases, from personalized medicine, preventive healthcare, to therapy discovery and tailored fintech services. So you don't have to, because it's a managed service, you don't have to worry about the certification or, creating your environment, and comes up with enterprise grade SLA. All right. So when we look at our customer base, we see like there are three common objectives. The first one is around the modern data warehouse, where customers want to go ahead and democratize the data from untapped sources. Then there is advanced analytics, where one wants to get deeper insights from ML and AI. And then lastly, they want to get the insights faster in real time, which is another area that we are seeing tremendous growth as well as adoption. So if you look at the overall use cases and what customers can use or are using, whether you talk about retail to financial, where you want to do a risk and revenue management, or security to do actionable threat intelligence, or for real-time pricing optimizations, you will end up using Azure Databricks in literally all of these scenarios and use cases. So from an architecture perspective, like how do you architect an entire pipeline on Azure with Azure Databricks? So the first step is you start with a variety of data sources, structured, unstructured, from different applications, batch and real time. So you use Azure Data Factory to load the batch data to Azure Data Lake storage, or you end up using Azure Event Hub, Azure IoT Hub, or Kafka to ingest the real-time data. And once the data is stored in your data lake, that's where then you start using Azure Databricks to process the data, curate the data, let it go through different level of enrichments. You use machine learning ML flow on Azure Databricks, which is natively available to manage the ML lifecycle, deploy the ML model. And then finally, once the data has been enriched, you load up in Synapse data warehouse for it to be available in Power BI to serve your users, or you make it available in Azure Cosmos DB or Azure SQL DB as part of your operational database to serve it for your business apps. So that's kind of an end-to-end architecture in terms of from an overall perspective that we see customers using and what we recommend. Now, we talked about the end-to-end architecture. Let's talk about Delta Lake. What exactly it is? It's primarily bringing reliability, consistency, and performance to your data lake. So we have all heard about data lake, right? And it has become very popular. Like everywhere you go, every enterprise executive you talk to, what we hear about is digital transformation, being data driven, and so on. And digital transformation basically helps with improving the customer experience, internal efficiency, or optimization based on the domain that you work on. And then being data driven means being able to analyze more data. So effectively, how have enterprises gone about to meet these two things is by building data lake, because it's economical to store the data, and it's flexible because there is no fixed schema upfront to impose or schema being imposed. So while these advantages are there with data lake, there are a couple of deficiencies as well, because data lake comes out to be a bad dump of data, which poses reliability challenges, and we'll talk about what those are, and as well as performance challenges. So Delta Lake is the new thing. I wouldn't say new; it has been already been in adoption for last couple of years. So it's something that addresses the deficiencies of data lake by bringing reliability and performance by providing the same economical cost and flexibility that you would get on data lake. So if we go back, even before Delta Lake, when you would start a data journey of big data, you would have to deal with these challenges. Your data can be complex, different data formats. You have different kind of workloads, and you have to think about different solutions. And then you have different systems when you have to somehow connect to different systems. These problems are already solved today with Azure Databricks. So Azure Databricks already supports different data formats. You could use batch and real time together. And as a first party service, it's natively integrated with the rest of the Azure ecosystem, whether you talk about Azure Data Lake Storage, Azure Event Hub, Power BI for visualization, and so on. It's all natively integrated into the heart of Azure ecosystem. So you don't have to worry about going through some ad hoc way of connecting. So while these problems are solved, what are the problems with the data lakes? So as I talked about, there are reliability challenges. Your jobs could fail in midway, and there will not be any transactional guarantees. You could end up in a bad situation with an inconsistent data. There is lack of schema enforcement. So basically, you don't have control over schema, and it ends up being a dump of bad data. So without guaranteeing schema, then you have to go through. You cannot have multiple readers and writers reading the data, reading and writing at the same time. So which creates consistency problems as well. So if you have a GDPR request to delete a data record, or you end up creating sequential pipeline, which is a big pain. What about the performance challenges? So in a streaming world, what you end up in data lake is lots and lots of tiny files, and basically you end up spending more time on opening and closing the files than actually doing reading and writing to the file itself. And then you end up using poor man's indexing, and if the schema has lots of dimensions, or the fields are chosen incorrectly, it doesn't help, because you end up scanning the whole data underlying, and then the perf slows down. So let's talk about Delta Lake and how it brings reliability to your data lake. So Delta Lake is a new standard for building data lake. It's open source, open format in Parquet, fully compatible with Spark APIs. And you can convert your data lake to Delta Lake with a simple command and start to take benefit of Delta Lake. So underlying, as you see, you just have to do, instead of dot format, data frame dot write dot format, you just have to write delta instead of Parquet, and then boom, your data is now become a Delta Lake. and I'll talk about the benefits shortly. So what is the secret sauce for Delta Lake? What we do is we keep version of the Parquet file, and as you know, Parquet is just a file format. We keep versions of the Parquet file, build transaction log, and add additional indexes and stats for performance improvement. What this enables is ACID transactions. So if we go back to the promise of Data Lake, it's a central source of all data that needs to be democratized, shared, accessible by employees across your whole company. Traditional data lake couldn't offer concurrency because we had version file, and because we have version files, transaction logs, and with this we can promise ACID transaction guarantees that enable simultaneous read and write on your data. I talked about the GDPR thing where one has to delete the user record, and to do that you have to go through a painful process of reading the entire data, then rewriting the whole data. So it's extremely painful. All that now is like super easy with Delta format. You also end up unifying streaming and batch data all on top of the same Delta lake, so you don't end up creating separate pipeline. I talked about the data quality as well, where the data lake would become a dump of bad data. Delta Lake provides schema enforcement, schema evaluation, allowing you to set guardrails to be flexible when you need it, but so you can literally start from a raw stage, no schema, to fixed schema, to evolving schema based on your needs. So, and then finally, there is this time travel where Delta keeps journal, ability to recover in case wrong updates are done. So you can see the state of the world at a previous point in time. Now, the next two benefits, file compaction and Z-order partitioning, are uniquely available with Azure Databricks, and I'll be spending some time to show a demo of the perf improvement and what these two improvements mean in the upcoming slides. Let's talk about Delta Lake time travel use case. So if you look at this query, what it says is select count star from my table timestamp as of this date, or timestamp as of current date -1. So literally you can go back to a previous point in time with the time travel feature as part of Delta Lake, and it has multiple applications. So it helps with audit history, data reproducibility, pipeline debugging, immediate rollback. So let's take a quick look at what these mean. So before I go into what this means, let's spend a second to see under the hood what happens. So when you write Delta Lake files, this is what you see in the file system. There is a transaction log, and then transaction log is basically a set of JSON files where each file is an individual commit. So if you look at this within the Delta log 00000.json, what it shows here on the right is the operations that are happening. So it adds two Parquet files, and then that gets committed as one operation. The second operation, which is 01.json, it removes two Parquet files and then adds a new Parquet file. So that again becomes new commit operation. So all this is recorded in a sequential manner. And your file in the Parquet format is in the partition based on how you would have selected as a partition column. So let's go into the time travel where I was talking about audit history. So literally you can see here it takes you can see the history of all operations that are recorded as part of the Delta Lake. It has types, user IDs, cluster IDs, notebook IDs, timestamps, and versions. And all you have to do is a simple command like display describe history events, and then you see these data. The screenshot that I have copied is for a query on top of Delta Lake, and you end up seeing these information, which could help you even for auditing needs. It has like user ID, usernames, and the operations, etc. So you get a lot of audit info that you might want for compliance or just debugging. Now, we talked about the data reproducibility. There is a wide variety of reason to use, like one could use it for machine learning, tracking ML models, or tracking like ML model drift. Say if your model accuracy is changing over time, you want to use one as a baseline and then go to a previous point in time and then see the model accuracy and then plot a graph to see how the model accuracy is drifting, or maybe it's just used for debugging as well. So that's another use case that you would see from time travel. So you do the same thing, select count star from the table as of a particular date. Now you could also do rollback. So one of the things, the GDPR case where say you had a bug that accidentally deleted user information, you can now easily fix that pipeline instead of going through the pain process of reading the entire data, rewriting it again. So in this case, what you're doing is insert into my table, and then you are using select star from my table's timestamp as of the current date -1, where user ID is XYZ. Or you could do the same using the merge into a statement. So what this is showing is how easy to roll back as part of the time travel feature. So you don't have to go through the pain of rewriting the entire pipeline or going to the start of your pipeline. What does it take to start using Delta Lake? So in the before, like if you have been using create table using Parquet, you just have to use create table using Delta. Or if you're doing data frame.write.format Parquet and save the data in a location, you just have to do .format Delta. It is as easy as it is. There is no extra cost. It's built into the product, whether you use standard or premium tier, it's available in all, and you could use it right out of the box. So now we know, we started with the data lake. We covered the Delta Lake on top of it. So let's take a look at, what this means at scale on Azure. So going back to the previous architecture that we walked end to end, the step one, as we talked about, is loading the raw data into Azure Data Lake storage. You're using Azure Data Factory for batch or event or IoT Hub for the streaming or scenario. And then you land that data. As you land it as a Delta format. And as we learned, it's just a format. So literally this step doesn't change. What you're doing is it coming to the same data lake storage. And if you have existing, you just have to change the format, save as Delta format. And you start getting all the benefits of reliability, consistency, performance right on the raw data itself, which we call as the, bronze in some sense. Now, as you go through the process of enrichment, you do join, clean the data, transform the data, you develop, train, and score ML models with Azure ML and ML Flow. And so your data now becomes available as silver table, goes through one set of enrichment. And again, it's in Delta format. And then the next is finally the gold table, where you end up creating business summary aggregates and all that for users to visualize or query the data, which is what you land up in Synapse SQL for users to visualize the data, which is your step 4, where like loading the data into data warehouse or loading into Cosmos DB or SQL DB for your real-time applications. So what you end up doing here is, the second layer of the storage, which used to be just a data lake, it has now transitioned to a Delta Lake. And so you end up realizing the gains of performance consistency. If your business analyst wants to consume, they can go to gold format, or they can go to Azure Synapse. If your regular data scientist want to consume silver format, they can go ahead to the step 3 silver table. The idea being that with Delta Lake, you get all the advantages that it offers. And this is just one illustration of how the different stages of enrichment goes. Now, depending on your use case, you may end up having one extra step or one less step. But the idea is, like Delta Lake is de facto for consistency, reliability in this space. So let's talk about the performance tuning. The two things that I talked about, which about Delta Lake that we haven't covered so far. So the first is the Z order, and the second is the file compaction. So before I cover Z order, basically, as I was mentioning, like you partition the data on the low cardinality columns, and you try to aim for at least 1 GB for partition. Now, this is something you have been already doing, and you may not end up gaining all the performance benefits. So with Delta in Azure Databricks, what you end up getting is Z order. Z order is a technology that basically co-locates the related data together in the same set of files, which enables data skipping. So you partition on a low cardinality and then Z order on a high cardinality, and you end up getting multi-dimension partition scheme that makes it easier for fast access of your data. So you don't under the hoods, the engine doesn't spend a lot of time in scanning a lot of files or lot segment of data, but rather only what it's needed for the query. So that's one. The second one is optimized, that you can run in a separate cluster, which reorganizes and compacts the file to perfect file size and mitigates the small file problem that I was talking about in the real-time streaming scenario, where you end up lots and lots of small file and there is time taken to open and close the file. So with the optimized, which can be run on F or FSV2 series, it basically compacts the file, and that way you don't end up paying the perf of opening and closing those files. Rather, you spend more time in the actual reading or writing. So literally, like some customers, just by doing these two, have it, end up getting up to 100x performance improvement on these performance optimizations. So let's take a quick demo on how this looks in reality. That way it becomes more real for you. So let me go ahead and share my workspace. Tim, is my browser visible for Azure Databricks demo, or anyone?
Yep, you're good to go. We can see it.
Awesome. So before even going to the notebook, this is where how you create your Azure Databricks workspace. So as I was saying, like literally, it's a click of a button. So you end up providing the resource group, workspace name, etc. And so let's give it a name. And of course, you can provide your like network related security information. So it is doing, it looks like there is some validation happening. Okay, I did not end up providing the workspace name. You could choose, VNet virtual network configuration. For example, if you want to deploy the workspace on your own virtual network, you can provide tags for cost management. If, for example, you have multiple departments using the same workspace, you can create tags that will, propagate to the underlying clusters, through which you can do cost management or chargeback. And then that's it. You review and create. It was as easy as it is. And so once this is created, then you go ahead and launch the workspace. So let's say you go ahead and launch this, and this is what you will
Hey, Bhanu,
see.
real quick. can you zoom your browser a bit?
Okay.
Thank you.
Yeah.
Like maybe can change that to 125%.
Okay, let's see. Oops, it ended up being more.
So you see there are 3 dots in front of your name. If you click on that, there should be an option to zoom. Yeah, that one. Perfect. Thank you.
All right, thanks. So basically, what you end up, you end up launching this workspace, and if you haven't already seen, like this is how easy it is to create a cluster. You enable auto scaling, you set auto terminate, and so on. So not going into detail into all of this, but going to the notebook experience. Once you create a cluster, if you're using cluster pooling, then you end up getting a cluster within seconds. Or if you just create a cluster without cluster pooling, it could take a few minutes. But once the cluster is created, you write your own notebook to run a job. And so in this demo, I'm going to show you, how by using Delta Lake, when you create the table as a Delta format, and then you use the optimize and the Z order optimization techniques that I talked about, how it helps with the performance improvement as compared to without using them. Uh, Before going into the demo, I want to mention that I'm not a doctor or physician, but this data is using the COVID-19 data set, the unfortunate time where we are going through. But basically, this data set is available. So don't believe in the the facts truths of the data, but the sole purpose is to see on this data set what performance benefits that you can see by using Azure Databricks. So let's go ahead and go through this notebook. The first thing I do is basically list my Databricks datasets that comes as default on your Databricks runtime. So if you go ahead and create a Databricks cluster, you will see these different datasets. And so we have added this COVID dataset as part of the Databricks runtime. So here you see I have this COVID dataset. There are other datasets as well. Now, this data set has, this COVID data set has data, I think, more than May, but for this demo, what we are doing is only extracting, cleaning the data from January to May of this year. So there is a prep script that I run just to ingest, merge, and clean the data. I'm not going to run this here since it takes about a few minutes, so I'll just skip through this. But and it's run in a separate notebook, so you modularize your jobs. But this is done one time. Then once your data is cleaned and enriched, then you go ahead and end up inspecting the data. So let's go ahead and inspect what the data is available. So in the previous script, what I did was I created a daily COVID table to show how the and then I'm trying to get a sense of what this data contains and and so on. So let it give it a moment to run, and then once it finishes, we will see what schemas are there, what data points are there, and so on. And just to give you a glimpse of what it is in this, as you see, it's basically showing as part of the job for the different dates, the different province, country, and the different columns as part of this table. And so once this is done, this is where it end up creating the different data frames like map underscore popest underscore country and so on. So let's get it to run. Generally, it takes about 8 to 10 seconds for this to run. And once it is available, you can see the different data. So it has got the admin, the province, state, the country, region, confirmed cases versus deaths, the unfortunate things. Now let's go ahead and run this for King County, Washington, where I live. So let's go ahead and run this. And then what it's doing, it's selecting some of the columns from the JHU underscore daily underscore pop, the table that we went through, to get the number of confirmed cases and the deaths over the time from March to May. And so you end up seeing this graph. Now, as you know, like within Databricks itself, notebook, you have the option to visualize the data. So I can choose the value, the key, and so on, and then use the kind of display that I want to write in the notebook itself. So it's really helpful for data scientists if they want to do ad hoc queries. And then once it's done, as you see, this took about like 10.62 seconds. Now let's go ahead and normalize this data. So now you want to normalize this data to see the relative deaths per 100,000 people, and then normalize the time series as well. I see that I have 15 minutes remaining. So even though I allotted certain time, I wanted to make sure I cover give some time to the rest of the section. So I will go through this little quickly than actual running of the commands. But usually these takes like few seconds. But let's go into what I wanted to show. So you go ahead and after you normalize, you prepare the chart to see the relative per capita deaths over the whole United States. And this is what you see for the period from January to May. And then finally, all the previous queries that I did where I plotted this graph, as I mentioned, like this was done just on plain data lake. So if you look at this optimizer hints, what it says is run the optimize Z order by command on that particular table, and that will help performance of the query. So even if you don't use it, you will end up getting this hint to improve the perf. So let's go down and then go ahead and run this. So I have already run this where I created this as delta table. So as you see, I did write.format delta, and then I'm saving it into a temp location. And then I'm going to run this optimize and Z order that I talked about. So I did optimized on JHU underscore daily underscore pop underscore delta lake, and then Z order by a high cardinality column process underscore date. And once this is done, this is what I run the exact same query. And so the previous query, when you noticed, it took about roughly 10 seconds, and now I'm running the exact same query. This time it took close to same, but let it give it a moment to cache, and you would see almost up to 10 to 20x just by using optimize and Z order. Oh, I need to actually run this. Looks like I haven't run optimize and Z order, and that's why it's taking around 8 seconds. So let's go ahead and run this and then see the difference. So now I ran the optimize and Z order, and then let's go ahead and run this back. And as you see, it's like literally 0.4 seconds. So what was the performance that like the numbers were showing 8 to 9 seconds. When I ran this optimize and Z order, it became like literally 0.4 seconds. So it shows. And then if you look at the old query without the optimize, without the Z order, without the delta lake, it was like close to 9 or 10 seconds. So representing almost like 10 to 20x perf improvement just by these two. Now let's talk about some of the going back to the deck with introducing some of the new things that we have launched is the brand new Delta engine. So if you went through the Spark Summit that happened in the summer, you would have heard about the enhancement on Spark 3.0. So with Spark 3.0, there are a bunch of performance improvement. It has got the adaptive query execution, where the execution plan changes at runtime automatically to set the number of reducers and join algorithms. There are dynamic partition pruning, query compile speedups, optimizer hints, and so on. Now, and with that, now you already have Spark 3.0 available as part of Azure Databricks. We are going one step even beyond with the Delta engine. So if you look at the motivation of the Delta engine, like it's primarily taking advantage of the underlying hardware and then building software on top of it to make sure it leverages some of the hardware innovations as well. So if you look at the trends across storage and network, they continue to increase by 10x every decade, but the CPU's cycles continues to be the same. But there are CPU innovations going on at data level parallelism and instruction level parallelism. And so what we did, with Delta Engine, it's a completely rewritten engine in Scratch in C++. And that is what it avoids going back and forth from your Java runtime to the compiler language because of the fact that it's written in C++. Any CPU bound operations are very fast with this natively available Photon as part of Delta Engine on Azure Databricks. It's fully Spark compatible and then accelerates SQL and data frame workloads with native query optimizer, vectorized execution engine, and caching. So the query optimizer is already available, the caching is available, and we have got the Photon available as a private preview where customers are already running it and for some of their production and sharing feedback as it is in preview. So going into nutshell into what these improvements are, the query optimizer, it basically extends the Spark cost-based optimizer and adaptive query execution with advanced stats, and it can literally give up to 18x performance improvement for star schema workloads. The caching, again, the improvement here is that it transcodes the data into a more CPU efficient format by leveraging the NVMe SSDs, and you end up getting up to 5x performance improvement for SCAM for literally any workload. And this is the brand new Delta engine with Photon that I talked about, where it exploits the data level parallelism and instruction level parallelism. And it is not just optimized for like as your business needs change, you end up creating data models. So with Photon, like it even optimizes the data structures that are not optimized. So for example, like faster string processing, regex and all that, those workloads get huge benefit and boost with Photon. So if you look at some of the details in terms of what kind of operations are faster, let's take a quick stab at it. So I mentioned that it's available as open source Spark API. So there are no changes in the proprietary API. The engine is completely transparent to the users. They will not need to select which runtime to use. So it goes even one step further, because with the regular Databricks workspace, you have to specify the DBA runtime, the VM SKUs, and all that. With this, you don't have to do all that, and it's completely transparent, and the engine is completely transparent to the user. And it has more efficient memory management. It's optimized for the modern hardware, and it has got native vectorized writer and improved speed at scale. So in terms of the operations, like if you are doing joins, aggregations, table and file writes, or regex expressions, or merging operations, all of these represent a substantial improvement in performance as compared to the native Spark engine. So in terms of the state, as I mentioned, it's available in preview running with some customers, but these are some of the numbers based on 30 terabyte TPC DS test. So if you just look at OSS Delta Lake with Spark 2.4 and compare it with open source Delta Lake with Spark 3.0, there is already a 2x improvement. Now, if you compare that with Delta engine that we talked about, there is a 2x, another 2x improvement. And then finally, if you end up using Photon, you end up getting 4x improvement. So you could see the numbers, like starting from 51,155 going into 3,220 seconds as part of 30 terabyte test. shows a huge improvement on the performance number with Photon. So to summarize in a nutshell, like what we talked about is we started with talking about how do we democratize, make the data available and accessible to all the users, different personas in an easy to use format and in a performant and consistent way. This is what it looks like. You start with your data in a data lake, then you convert that data into Delta Lake in your first step itself. So your data lands as a Delta Lake. And then you take advantage of Delta Engine, which is open source and can be used with any other Apache Spark service as well. And then finally, the Delta Lake, which brings reliability to your data, you end up, with Photon and improvements, performance and consistency improvements happening with Azure Databricks. You cater it to different workloads like machine learning, data science, BI, and streaming analytics. You can try this out today. I have given a link, aka.ms/learn Azure Databricks, and I'll be also sharing the slide. So you can look at it. With that, I'll pause here for questions, and thank you again for coming for this Data and AI Summit. Global Data and AI Fest.
What's nice, Bhanu, is that thank you for the great presentation. Is that Adam Wasserman was actually able to answer all the questions so far, so we're looking good.
Oh, thank you, Adam.
Oh, wait, there's a couple others. No, Adam answered them all.
Awesome. I'll see if there are more questions. Otherwise, I'll give it over to Adam.
All righty, thank you. I don't think there are any more. So, but we can't thank you enough. Thanks for presenting and doing our keynote for us.
I think there is one more. It just came in regarding the pricing.
Mm-hmm. Let me take a look.
Oh, can you provide the link to the performance benchmarking results?
Yeah, so it's a part of the deck, and it's run by independent people. So yeah, it's you can have access to that link in the deck.
Okay, thank you very much. All right, so that was Bhanu Prakash from Microsoft, and then now we've got Adam Wasserman from Databricks to present a more technical session around Databricks. So thank you very much.
Cool, thank you, Tim. I do see one more question that came from Sri. I was actually answering his questions in the chat, so hopefully I can do a little bit better job verbally. So around the COVID-19 data set that Bhanu was presenting, basically the way Databricks data sets work is there is a file system that comes by default with the deployment of Databricks. So that's going to underpin sort of what you're deploying with Azure Databricks. And since that's managed and hosted for you, we're able to kind of pre-package and preload it with certain data sets. And in this case, one of those data sets was what Bhanu showed, which is the COVID-19 data set. So it's really just about going into your deployment of Azure Databricks or your workspace and effectively running something like spark.read on that file path. And you can link to that file path as if it's sitting on the local system because it's tied to the deployment. So that's why you're able to reference it with, you don't really need a fully qualified file path. You can just use DBFS if you'd like for storing data sets. We do recommend using external stores for obviously larger workloads and larger data sets, but hopefully that's a better job of it. Sri, I believe my contact information will be posted. So if you have any further questions on that, happy to follow up offline with you. Alrighty, let me go ahead and present here. And then let's see. Alrighty, you guys should see a slide that says Databricks or data science and machine learning on Azure Databricks. So before we get started, thank you. I just want to introduce myself. My name is Adam Wasserman. I'm a solutions architect at Databricks. I've got just over 4 years of experience in the data and AI space. Every day I get to work with customers that range from the smallest of startups to the largest of Fortune 100 companies, government entities as well, and those that help government entities. So really very much covering the broader spectrum of sort of folks that use Databricks and Azure Databricks. So really excited to be here today presenting to you guys and just some more information. So prior to joining Databricks in actually March of this year during COVID, most of my time was actually spent at Microsoft working with fairly large and strategic customers on their analytics initiatives. So I've had the opportunity to see pretty much everything. There's obviously use cases all the time that are a little bit more nuanced, but generally I think everybody's trying to move towards the same direction, right? It's really about getting value out of data, and there's a lot of different ways you can do that. But today I want to talk to everybody about how you can do that, specifically from a data science and machine learning lens right here on Azure Databricks. So like I said, it all starts with unlocking business value. So I think oftentimes we get very kind of deep in the weeds with programming and want to kind of do it all, and that's awesome. And I think it's super important at the same time to tie that back to what does that actually mean for the business? What is that driving from an organizational perspective? And so when we think about data, there's kind of two main components of getting value out of that data. And this is one of which we'll focus on today, but really those are machine learning and analytics. And so the most successful companies are able to effectively operationalize both of these and have them work in tandem and in concert to further their business initiatives. And at the end of the day, there's a small few organizations that are doing this really, really well. And you might ask, why is that? Well, it's extremely complex. If this slide is any indication, the entire reference architecture of what we would consider doing it right. So going from ingesting data to serving an analytics kind of layer on a business intelligence report, or serving a machine learning model, it's all pretty difficult at the end of the day. And if you think about Gartner's perspective on this, they say that only 1 in 5 analytics projects will succeed in the next couple of years. It's a pretty low success rate. So I think we can do better, right? And I think it's that exact complexity that is core to what Azure Databricks aims to solve. So we know what not so good looks like, but let's dig into some of the core issues. And some of these were very expertly covered by Bhanu, so thank you again for sort of preempting this section of the day for everybody here. But we can boil it down to 4 main challenges. Data is extremely messy, very siloed and slow in a lot of cases. And so when we think about data platform teams, this is more the struggle that they're facing, right? Your data engineers, maybe some DevOps engineers, as sort of an orthogonal point. So that this is definitely one of the major challenges. We talked a little bit about with Bhanu, Delta Lake, and how that can help solve some of these challenges. So the second challenge is ML is hard, and operationalizing ML across teams successfully is even harder. So this is a struggle for the data science folks and machine learning engineers in the room. The third is analytics. So not being able to harness all of your data and only just a subset, there's a lot of potential wasted, right? We may want to look at our entire historical data set for things like analytics or even machine learning. So this can affect almost everybody. And then the fourth and final one here is enterprise readiness. So things like security, reliability, and automation are oftentimes missing today. So this is definitely a headache for for folks like the DevOps engineers, security engineers, and engineering teams in general. So to address these issues, and really the second point around machine learning specifically, today we're going to focus on the prep and train section of this architecture diagram. I know Bhanu showed something very similar to this, but I wanted to orient everybody around where we're going to be focusing our time together. And it's really about how we can address the challenge of operationalizing machine learning and uniting data teams through the tight integration of Azure Databricks, MLflow, and Azure Machine Learning. So when it comes to ML projects, we found that there are really three major challenges most teams are facing. All companies have lots of data scattered in multiple systems, and they spend an exorbitant amount of time cleaning data sets and prepping for analytics. And in the recent past, we've seen an explosion of machine learning frameworks, right? So the TensorFlows and the PyTorches of the world. And these are extremely powerful frameworks that data scientists oftentimes need to use to solve different prediction problems. But the overall complexity of working with these frameworks into a real production pipeline is more often than not overwhelming. So maybe there's a better way to do things, or an easier button to press, right? And then finally, and probably most importantly, data scientists and data engineers kind of operate in silos more times than not. So this organizational separation, we believe, is truly slowing down innovation. So if we could unite data teams, through technology, that would be incredible. So this is precisely why Azure Databricks and Databricks created MLflow. And so to give a little bit of background, if you're not familiar with MLflow, it's an open source platform for the end-to-end machine learning lifecycle. And MLflow truly unifies data scientists and engineers across the ML lifecycle. And what this does is, as you can see on the slide, enables teams to share their models and reproduce results more consistently. And as a little fun fact, we're now seeing well over 1.5 million downloads per month on a consistent basis, and trending upwards with roughly 4x year-over-year growth. So lots of adoption in the marketplace, but why is that, right? So if you look at kind of the flow, no pun intended, of this diagram here, we've got the ability to do data prep, model building, and model deployment. So really broad coverage of the entire ML lifecycle, and bridging together those steps that are oftentimes extremely complex and really grueling to deal with, and packaging that up in a very simple interface and platform to work with. And just to dive in a little bit deeper, MLflow tracking provides the ability to track all experiments in one place, irrespective of deployment location. So if you're cloud native, you're on-prem, or maybe you've got a hybrid cloud architecture, that's totally something that is in the realm of what MLflow is intending to cover. MLflow also integrates with Delta Lake very, very tightly. So that provides you with full data traceability for your models. And we'll talk a little bit about what that could look like here when I jump into the demo. And then finally, we've got MLflow model serving. So this enables data scientists to take MLflow models that you've built through your ML pipelines and deploy them anywhere, facilitating increased collaboration. So by democratizing not just your data, but what you're doing with that data in terms of machine learning and data science, this very clearly sets you up for success. And there are many new features, coming inbound all the time. And just to kind of quickly cover what we'll specifically be focusing on today, once I dive into the notebooks, this is a very sort of general, flow or pattern that we see when using MLflow, and also kind of sample some of the integrations that you'll find. So you can work with any sort of framework of your choosing for machine learning or data science, and work through model building. You can track that model, so gathering those parameters, metrics, artifacts, and metadata about that pipeline or those model runs. And then you can use the model registry for versioning, and then you can use model serving if you'd like to serve your models in a lightweight capacity. The great thing about MLflow, Azure Databricks, is that they integrate very, very tightly with Azure Machine Learning. And there's tons of great features in Azure Machine Learning that you'll likely want to make use of in your sort of ML journey. So it's very important that this integration experience is top tier, top notch, and we made sure of that. So it's definitely something we'll see today. So let's, without further ado, jump into the notebooks here. Awesome. Cool. So as a kind of precursor to this, I will say I ran this super late last night. I'm Denver based, so basically ran this last night, and we're not gonna kind of run through this live just due to some of the runtime variance in some of the cells, because we are kind of doing some model training and multiple iterations and things like that. So to save time, get to the point, I've pre-run this. I will also kind of talk through this end-to-end ML demo, and it's going to showcase how we can use Azure Databricks, MLflow, and Azure Machine Learning working in conjunction, working together to basically do the following. We're going to read in some data. We're going to build two different machine learning models, one with Spark ML and then the other with scikit-learn. We're then going to track and compare those models using MLflow right here in Azure Databricks. And then once we're ready to move towards production, we'll move one of the models to the model registry, talk through what that might look like. And then finally, we'll go through two different deployment types. So one production deployment as in batch with a UDF or user-defined function, and the other using a REST endpoint with Azure Machine Learning. And we'll actually pivot over to Azure Machine Learning briefly to take a look at what that looks like from an integration perspective. So our objective here is to take or use time series data from 5 different sensors, and these could be arbitrary sensors, right? For simplicity, we went with kind of IoT sensor data. This could really be any data that you'd like to use. And what we're going to do is create an ML model that can make predictions about the 5th sensor based on performance from the first 4 sensors. So kind of a simple use case, but this is really intended to kind of show the integration of all of the different systems and the art of the possible here. And if there's any questions, feel free to post them. I can't see them right now, but we'll lean on Tim and team here to kind of interrupt me if there's anything super duper pressing. So if we scroll down here, and again, this is going to be available following the presentation. The data that was used in this demo will also be available in this cell, so command 3. But this is the general trajectory that we'll be following for today. And so at first, what we'll do is we'll install some dependencies. So we want to install the Azure MLflow integration package. So I've already done this, so I got a kind of reminder of that in the output console here. But if you don't already have this installed, definitely a good idea to do that to make sure the integration works. Then we've got other dependencies, so just pulling in things for PySpark dependencies, MLflow, specifically around the 2 packages that we'll be using to build our ML models and pipelines. We've also got some Azure ML dependencies as well. So first things first, any good data scientist knows that in order to actually start proceeding with machine learning in any sort of real capacity, you need to understand and know the data like the back of your hand. That way you're able to do things like feature engineering or whatever you'd like to do to get the data in the right shape for your ML pipelines. So I've gone ahead and set up this same data set in Databricks. The way you could do that is basically if you go to this data tab on the left-hand side here, I'm just operating in the default database, but you can create a new one if you'd like. And then basically from there, if you want to add this via the UI, you can. You can also do so programmatically. And really quickly, I'll show you what that would look like. We've got sensor data. So this will upload into the UI, and then we can actually use this visual tooling to do some very light transformation of that data. So things like column data type definitions and things like that. So once this is done here, we can click Create Table with UI. We can use the cluster that I have running, appropriately named here. And then let's say we wanted to do something like sensor 2. Once the data loads, we'll actually see that the first row is the header. So we're going to want to check this. You can customize your delimiter, and then you're off to the races from there. I think this is lagging because I have had this tab open for for quite some time. But there it goes. Okay, so for things like your sensor data specifically, you might want double types, right? So very easy to kind of come in and make adjustments on the fly, and rename columns. And then if we were to do this right now, we can create that table, and so that will now display in the data tab. So very easy, very quick to upload some data and get started. Well, let's go back to the notebook. And so once you have this data in, I've just read this in using the spark.table call, and I filtered it where device ID is equal to the first device. So if I run a display, you'll get at first you'll get a table-based output, but you can also kind of chart or plot any data you'd like very quickly and easily in Databricks. I know Bhanu kind of covered this, so I'm not going to go over it, but plot options is a really good and easy way to kind of manipulate this, change your visuals. If you want to change your visuals on the fly, you can. So if I wanted to select any other of the available visualizations right here in the notebook, I totally can. And this is really useful to see, maybe you're observing for data distribution or data skew. You could do that in a quick and easy manner, maybe understand how you'd want to split your data for training and testing. But once you have the data, we can go ahead and effectively proceed with the rest of the show here. Today again we're going to be showing the integration among 3 different services here, and one of the bigger points to call out here is just the sheer amount of flexibility that you have. So not only are we working with 3 different services, but we're kind of bending and flexing to the needs that we may have, right? So being able to use Spark Pandas UDF for batch scoring, or deploying a model as a web service in Azure machine learning. So lots of different options, lots of flexibility here. In every use case in every organization is different, and we understand that. So we wanted to showcase kind of the sampling of offerings here. To make all of this work, you will need to link your Azure Databricks and Azure Machine Learning workspaces. To really quickly show you what that would look like, if you log into your Azure portal and go to your, if you go to your Azure Databricks deployment, I've already linked mine, but you will see a little box here that says link to Azure Machine Learning. You would go ahead and click that, and I think it's maybe 3 to 4 different clicks, and you're off to the races. Not a lot to it, but definitely a precursor to this integration working properly. So, and I've included a link on documentation and such, so that there are clear steps with screenshots and things like that. So from here, we'll get started. So we're going to set our MLflow experiment name. I've just named it basically the path to this notebook in the Databricks file system, and you can use MLflow set experiment to appropriately set that experiment up. So the first model we're going to walk through is a machine learning model with Spark ML. So this is, if you're not familiar, it's a distributed machine learning framework where you can effectively run things like categoricals and numerical regressions. So there's lots of different ways to kind of tackle problems with Spark ML. Really useful library, but we also understand you may have existing ML pipelines already in production that you want to retroactively distribute. So there are easy ways to do that without having to go, make the jump all the way to Spark ML right off the bat. But to start, we'll go ahead and basically instantiate some ML dependencies, and then we'll split our data into, so the same data you saw above, we're splitting into our training and test data sets. And what we've done is we've held out 30% for testing. So pretty traditional split here. And you can see the resultant data frames down below and their according schemas. If you wanted to take a look at the data, you could, if you ran a display on either of these variables that we've created. From there, what we're going to do is basically create a vector of inputs and outputs for the regression pipeline to follow. So scrolling down, we are now basically defining our regression model here. And so you'll notice the use throughout this regression model definition, the use of ML flow commands. So you'll see ML flow start run. You'll see ML flow log param. You'll also probably see metrics logging and actually logging the model. These are important. These are important. But one thing I wanted to mention is that in this example, I've explicitly declared ML flow calls in these pipelines. But I really do encourage everybody to check out ML flow auto logging, which will effectively strip out the need for me to do this, and it'll automatically log what we're doing manually here today. And if you want more information on that, happy to kind of send links along after this. But now, once we've defined this sort of pipeline, we are able to actually run through and iterate through our number of trees and then our depth list. So we're able to basically take a for loop and loop through this pipeline. And so we're looking for, again, those sort of predictions of values for sensor 5. So it's really appropriate to use a random forest regressor, or something that can regress to a numerical as opposed to a categorical. And so that's what this code is doing here. And you can see, certain things that we want to log as part of our pipeline. So things like maybe our MSE or R squared, maybe some run info from the pipeline run. That's all going to be kind of matriculating into ML flow tracking, which I'll show you very shortly. So once we have our outputs, you can have them feed out to the console, which we did here, which is how most folks would do it kind of before ML flow existed, right? You just display your outputs, maybe jot them down in Excel or on a piece of paper. So it's really important for reproducibility purposes that we're logging those parameters and those metrics and keeping tabs on the important work that we're doing. Before we do dive into the ML flow tracking, I do want to kind of show you guys just another sample of a ML model and ML pipeline, but this time using scikit-learn. If you're not familiar with scikit-learn, basically scikit-learn is definitely more popular on sort of the single node data science side. But today we're going to actually take that, and using a pandas data frame, we can effectively distribute scikit-learn using the power of Spark under the hood. So this is incredibly important because we're able to follow the same or a similar flow in a similar framework and approach to solving the problem. So there's a lot of standardization just from a syntax perspective, but also we're able to really do great things like logging the parameters, metrics, and model artifact, just like we did for our previous pipeline. And what this does is, as you can imagine, if you scaled this out, you could start to evaluate or compare, these runs based on model accuracy and efficacy. So we'll just walk through this really quickly. Again, you'll see sort of the use of ML flow calls here with start run. What this does kind of in the background is make sure that your run falls under this sensor regression name nomenclature. so that everything's categorized very nice and neatly in MLflow tracking. But yeah, again, we're just leaning on a pandas data frame here for distribution purposes, and then we're able to effectively walk through the pipeline. So we're going to fit, train, and score the model using the random forest regressor again. We're gonna then gather metrics, log those metrics, and then we're going to build a metrics table. So this piece here is actually what, again, you might want to do if you didn't have something like MLflow and MLflow tracking. But since we do have those, I'll show you just how easy it is to kind of actually get a nicer and neater comparison than what you're seeing down below. And one other thing I want to call out is we're grabbing this last run ID for kind of the next step, which would be deployment, right? If we know that the last run is something that we're going to want to deploy, we can basically parameterize it and pull it out of the sort of training pipeline here. So at this point, I want to show you guys exactly what I've been talking about up until now with the MLflow tracking feature. So if you click on this experiment button at the top right, this opens the experiment runs pane. So you can see all of the runs that I performed late last night, and all of the according metrics and every sort of output from the model that we built. And you saw that kind of happen in real time. And so these are just the outputs of that. And so, from here, this is just a relatively small number of runs. As you scale out your operation from an ML perspective or data science perspective, it's very likely that you're going to have more than 8 runs in this pane, right? So this is great if you've got a small number of runs, but what happens if I have quite a few runs, maybe somewhere in the hundreds, and I'm really using the power of Spark and distributed compute to try to optimize my model as best as I can by testing as much as I can. So with that enhanced test coverage, if I move over to the experiment UI, which we're doing right now, you'll actually get, you're greeted by a pretty nice view here. Again, it's just 8 runs, but as you can imagine with more, this is a little bit more manageable. But let's say out of hundreds of runs, I wanted to just compare 8 because I could see at the surface there was something about those 8 runs that was just piquing my interest, right? So I can go ahead and select all or just a subset, and then I can compare those. And so this is a even nicer view of how you can kind of slice and dice each run, the run name, the time that it was run, and then all of the parameters and metrics that we collected throughout the pipeline process. What's great about this view is that you can map visually, our model versus our metrics. You can map your number of trees to see the correlation with metric outputs. So lots of fun things that you can do here. Obviously, I'm not a PhD data scientist, so I haven't fully gone in and tuned everything appropriately. But I think they're at a pretty good state with very, very minor touch points from me. So from a visualization perspective, this could be useful if you've got a lot of data and you want to be able to quickly pull out outliers or anything like that. And it'll tell you, exactly which run this is associated with. So let's say, at this point, we want to take this model, because I think the next logical step would be to register the model and kind of start to apply some versioning in some form to this, right? So let's say hypothetically that this run that I'm hovering over here was the run that I wanted to move into my model registry. What I could do is, among other things, do things like reproduce the run. So there's a really neat button here that makes it really easy to kind of go back in time, if you will. And this is really where the integration with Delta Lake from a data versioning perspective also plays in, because you can not only go back in time on your machine learning pipeline runs or model runs, but you can also go back in time on data with Delta Lake. So combining those two, you can effectively and accurately reproduce where you were at that point in time, even if that was days or weeks back. So very, very powerful stuff here. So if I wanted to reproduce the run, I can clone the notebook, and attach it to the cluster. And if I click confirm, this would actually just reproduce that run and bring me right to it. So good stuff there. Again, we've got our parameters, metrics. We can also tag. So if you wanted to tag this model, I can just say owner Adam Wasserman and add that tag. So you can do things. Oh, this is okay. There's a linkage error here, but you can do things like add tags if that didn't get thrown. And then another cool piece of this is actually the artifact output. So if you remember back to what we were doing with our MLflow sort of artifact when we log that model, this is the output of that. So you get your actual machine learning model, you get your Conda YAML, and your pickle. So all of these things are really important because this is your sort of model definition, and it's going to help you kind of bring it into the model registry. And so I've already gone along and registered this model, but you would see a blue button, very similar to the one you see at the top here, UI wise, but it would say register model. And if you click that, you have the option to basically very quickly move it into the model registry. So let's go ahead and open that up and see what that looks like. So this is, again, the same panel, but what's great is now this is sitting in the model registry, and I'll show you another kind of slice of what this looks like. But specifically, we're on version 2 now because I ran this twice, and we can basically do things like request a transition to staging, production, or I can archive this. So really powerful stuff. If I have elevated permissions, or this is a really one-off kind of dev environment, I could just transition it myself. But let's say I wanted, this was a great we saw great model efficacy and accuracy, and we want to move this into production. I can go ahead and do that. So might need a refresh here. That might be the issue. My internet's a little crazy today. So basically here now we see that request, right? I just tried to transition it to production, and someone else can come in and approve or reject this request based on what they're seeing. And so let's say I was to approve this. We can also transition whatever is currently in production under this specific model, and we can archive that, or we could choose not to. That's entirely up to you. But let's go ahead and confirm. And so what I'll do is click on models again. And so this is the overarching sort of model registry view. And now you can see exactly what we just did here, right? Latest version is 2. We just moved version 2 into production. It's 8:30 my time, probably 10:30 for most of you guys. So that's effectively how we can now, go from development to actually training data and defining that model. And then kind of moving that into production or staging if that's your preference for something like this. So really good stuff here. I think from here, what you could do is effectively, if we go back to the notebook, we can talk about model deployment. So we've got all the recipes for success to really move this into production, right? So the first deployment model that we're going to talk about is using batch scoring. So we can leverage MLflow APIs and the scikit-learn model that we built, and basically productionize this and batch score against it. So the way what that would look like is we could create a very simple UDF called PyFunk UDF using the MLflow library, and we're just going to feed in our model URI, which again, if we scroll up, we just pulled out of the last run ID. So this is going to directly reference the last run we did of that scikit-learn model. And so from here, what we can do is load some scoring data into a Spark data frame. So this is basically the same table that you guys saw at the beginning of the demo, filtered for device 1. And then from here, we'll want to actually score against that in a batch capacity and make some predictions. So we're going to, again, regress towards a numerical using that scikit-learn random forest regressor model. And so we can run this and evaluate it using the display command. That'll basically force this to run and display the output below, which we see right here. So we can see, if we compare our Sensor 5 actuals versus our Sensor 5 predictions with a very lightly tuned model. I quite honestly spent very little time on this. We can basically get actually really close to the right number. So imagine if I had spent just a little bit more time, we could probably actually almost be dead on, which is great. And when your variance is low, that's a good sign. But that's a really quick example or snapshot of batch scoring in Azure Databricks using MLflow. But I know a lot of folks that might not be good enough. You might need to serve a model as a sort of a web service or REST endpoint in Azure Machine Learning, or you may want to do other things with that. And so going back to the democratization, that's where this really hits the road. So the way that this works is through the integration between Azure Databricks, MLflow, and Azure Machine Learning. We'll effectively use ACI to kind of containerize this image or snapshot of the model that we built, and we'll deploy that directly into Azure Machine Learning very easily and quickly as a web service. And now I've actually gone ahead and just deployed everything all up. So everything from the Azure Machine Learning resource in Azure using the Azure Core package. I've also basically built out the definitions for our Azure service and our Azure model. So I've done all of this as kind of additional steps. So I want to call that out ahead of this, but we'll see down below how we could actually score against that. And then subsequently, we'll actually just go in and check it out in Azure Machine Learning, because why not, right? So from here, this is very, very simply just a call to create the actual Azure Machine Learning resource. You guys now all have all my credentials and whatnot, so have at it. And then from there, what we can do is name our experiment. So again, I've changed this from what we had originally and made it a little bit cleaner and just called it ML101. And so then we can define our service and our model. So using a very simple MLflow Azure ML deployment call, we can feed in our model URI, which is based on that last run in our scikit-learn pipeline. We can declare what the service name is, and then we can define our, what our workspace is and make this a synchronous call. So this is really, really good stuff because we're taking that model and it, very verbose fashion shows you what's happening here right in the output console. So we register that model, deploy it as a web service, and we get a nice big thumbs up here. So I'll stop here and kind of pivot over to the Azure Machine Learning side of the house here. So Azure Machine Learning is a super duper powerful tool. I'm not going to cover everything end to end here. There may be other sessions on that, or folks that are better equipped to do that. But I do want to show you just how easy this integration was. So if we go to this model section on the left-hand panel here, we can see once this loads that our model has populated directly from the run that we did, or that I did late last night, and basically come in here and understand metadata, so attributes about the model, any artifacts. So the cool thing is the same artifacts that exist on the MLflow side in Azure Databricks now exist in Azure ML. So you can kind of run with this and manage deployments from here if you'd like. There's a lot of flexibility, as I said, so really good stuff. And then the even cooler thing is the endpoint, the REST endpoint that we just created to serve maybe larger use cases or a broader audience. That's right here in Azure Machine Learning. So I can go ahead and click into it, and we should see that our REST endpoint is existent. In fact, our deployment state is healthy. Everything checks out, looks good, and this is really a good example of bridging the gap between two extremely powerful services and all the great things that you can do right here in Azure Machine Learning. So I will pivot back over to the notebooks, and now we're just going to score against that, right? So I can do that right here in the notebook. To do so, I want to maybe just for example purposes create some data that we're going to use to call that web service. And I've done that with just one row effectively, and a very simple schema that we're used to within this demo. And so I've got my data, right? From there, what we're going to do is get our web service URI. So we're able to call that using that one of the imported libraries that I've referenced earlier. And then finally, and lastly but not leastly, what we can do is create a function called service query. And what this can do is hit that web service directly with any data that we feed in. So you'll notice the input data argument here in our function definition. This is going to kind of matriculate through the function and its definition and provide a prediction at the end of the day. And so with one row and all the great training that we did earlier for our ML pipeline using scikit-learn, we're able to arrive at this 2.89 sort of ballpark number as a prediction. And if we go back to our data, let's see how accurate that would be. Maybe on average, it would be roughly 2.9. So not too far off for sensor 5 here. So I know I'm a little bit ahead of schedule, Tim. I want to kind of turn it over for questions at this point.
Sure. 1 second. Well, so we got 3 questions here. How does AML and ML flow work together?
Yeah, that's a great question. So today we went over, the integration more around the actual model deployment, and then actually deploying a REST endpoint to score against. So that's 2 dimensions. You can also log model runs, which I didn't demonstrate today. But you can actually see the same runs that you're seeing here on the right-hand side of my screen, or if I went to the experiment UI, you would be able to see these same runs kind of being in sync with Azure Machine Learning. So if you wanted to do analysis on your parameters and metrics and sort of the efficacy of the model, you could do that there as well.
Okay, let's see, which roles or areas does ML flow and AML fulfill respectively?
Sure, that's a great question. I think the obvious one, right, would be maybe the data scientist or the ML engineer, but one that we don't think about often is actually DevOps engineers, which are crucial to this process. I kind of look at DevOps engineers as kind of the glue to a lot of engineering teams, because they kind of have to pick up the in-betweens or the gaps between the teams, right? So whether that's from a technical perspective or otherwise, they're very crucial to this process. And so the way that ML Flow and Azure Databricks and Azure ML makes those folks' lives easier is it makes sort of calling this library, this framework, very simple. And so there's very clear standards, very well-defined expectations of what they would see. So procedurally, or from a process standpoint, things won't vary too much for the DevOps engineer. And so for their lives and for their for their sake of their sleep at night, because I know a lot of them will pull all-nighters, it's very good for them as well.
Let's see, thank you. The other one is there a link to machine learning with Azure Databricks and Azure Machine Learning Notebook?
Yeah, so I'll package up this notebook and send it out as a kind of extension to that. If you're not super familiar with Databricks, I want to show you guys how you would bring that notebook into your environment. So you might have your own sort of user path within your workspace. So if I went to mine and wanted to import a notebook, I could just right click and click import, and I can pull something right off my local computer. Or if you find a HTML version of a notebook in throughout the Microsoft Docs or somewhere on the internet, as long as it's compatible, you can bring that in via URL as well. So another way to do that same process would be to click this drop down arrow or caret at the top of the screen here, and then just import. Same UI will show. So very easy to bring in new notebooks. Cool. I'm running through the questions here. Were there any others?
Oop, I was talking on mute. After the 3 that we had, I think we're good.
Okay, awesome. I might be a little ahead of schedule, but I'm not sure. I'm not sure if there's a break. But just to recap for all the folks on the line, today we walked through kind of a really good overview of what data science and machine learning look like on Azure Databricks. We incorporated MLflow and Azure Machine Learning, so just kind of showcasing the tight integration among different services in Azure that can kind of help you as you work through your data workflows. And we've definitely only scratched the surface, so definitely encourage everybody to visit the Azure Databricks landing page and the documentation. There's lots and lots of great info that our content teams have worked collaboratively to produce. And yeah, again, just thank you all for your time today, and enjoy the rest of Azure Data and AI Fest.
Thank you very much, Adam. And we want to make sure he's not here, but want to shout out to Bhanu Prakash as well for kicking off the keynote. So Bhanu Prakash and Adam Wasserman did an excellent job. We will, let me see, we got one more question, Adam. Do you find testing and training cost effective?
Is that okay? So I'll try to kind of work backwards into what my interpretation of that. So the question was, do I find testing and training costs effective? I'm guessing this is more related to if you're running multiple iterations of this pipeline, would that be an effective strategy from a cost perspective? And I think the answer is really, it depends on what your goals are. For anything production-wise, so with Azure Databricks, we've got a lot of customers operationalizing things like recommendation engines for large, massive retail organizations. We've got predictive sort of automated pipelines for drug discovery in sort of the pharmaceutical industry. So lots of different avenues to tackle. So I think it depends on how serious or what the application is of these pipelines specifically that will warrant certain levels or a certain amount of testing and training of these pipelines. If it's kind of like a science project and you're just getting started, you may not need hundreds of runs, right? But if you're going to productionize something, you probably do want that to be as effective or as accurate as possible. And that'll probably even get better over time. And you can, test and train and retest and retrain as more and more data pours in, and account for things like seasonality or trends or patterns in the data that wouldn't otherwise be picked up.
All right, I got one more here. Let's see. Are there some specific references you can provide to help demonstrate how Azure MLflow can support discovery and definition of a new data architecture?
Yes, I can. Let me follow up with. It looks like Audie posted that. I'll follow up with some references right there in the chat.
Okay. Are there any other questions? Oh, wait, got one. Let's see. Oh, I see.
Awesome. I'll stick around just for a few 5-10 minutes here. If there's any other questions, I can answer them in the chat, and then we can. Yeah, we should be good to go from there. But yeah, thanks again, everyone, for your time this morning.
Thank you so much, Adam. All right, everybody, we got a little bit of time before we head on to our 11 a.m. tracks. Make sure you get some coffee, take a little break, and we will see you at 11 o'clock.
And just to add to Tim's note, we will not be using this Teams Live meeting for 11 a.m. track. So the session links are posted in the chat window, and you will also be having these links as part of your email from us that you may have received yesterday. So depending on the track, which track you would like to attend, there are 3 separate links. The Teams meeting link, please select either one of them. And you can also hop on between multiple sessions as well. So thank you very much for joining, and stay safe and healthy. And we will see you soon in the session tracks. Thank you.